that you have to, just because some of you are getting it right, but you're not like showing all your work correct, so you would lose marks. Majority of you are doing good, but there's a few that are a little off. So here we have tan x cos squared x over secant x. So you just rewrite them completely, right? No change. Then here the tan x, people wrote sin x over cos x, which was good. And then they wrote cos squared x, which was good. What is helpful to you, perhaps, is to just write like your numerator in its own square bracket so you know that that's a numerator. You don't have to, but it is helpful. And then divided by 1 over cos x. Because then you know numerator, denominator. Then these canceled off, and I was left with sin x cos x. And now it's all over 1. So full fraction, I can flip. And then I get sin x cos squared x. Then I go over here, and I immediately see, if I'm stuck, remember 98% of the time it's a GCF. So I can take a sin x out. When I take a sin x out of sin x, I'm left with a 1 minus sin squared x, which is off my formula sheet. This is cos squared x, so then they match. Left side equals right side. Don't forget that at the bottom. You agree? Okay, next one. So we have an LS. I have to erase that with my finger like that. It's going to work. And then an RS. We have to get a common denominator. So we multiply by cos x, cos x. So we get 1 minus cos squared x over cos x. 1 minus cos squared x is what? Sin squared x over cos x. And then I think I'm halted for now. Then here I'm going to go sin x, and then tan x is sin x over cos x. This is over 1, so I get sin squared x over cos x. And then left side equals right side. Oh my gosh. Okay, next one. Sure. So I'm going to LS, RS. We're going to go through it. Write a line down the middle. On the left-hand side, I can see that I can take a sin x out. Now, some of you guys are like trying to put the division of a sign underneath. I've seen it for a few people. You can only divide by sign like that if you have like an equal sign and you're like dividing the sign on this side and then you're dividing the sign on that side, correct? So it's when you have an equal sign that you can move over. I feel like I'm doing Thriller. But I'm not. I don't like Michael Jackson. Anyways,
You don't like Michael Jackson?
no, for numerous reasons other than his, just for numerous reasons. Now, that's my own opinion. So if you have here a term and a term, you can take the sin x out, but you can't just like divide it off. So it's a GCF, so you'd write it out in front, and you'd get cos squared x plus sin squared x, right? Because you're taking it out of this one, then out of this one. Now, cos squared x plus sin squared x is actually just 1. It's a Pythagorean theorem identity. So you just get sin x times 1 or just sin x. Cosecant is just 1 over sin x. So this would be 1 over 1 over sin x, which is literally just sin x, left side equals right side. And you'd be done. And I made that line aggressively long. Okay.
I like the little swirly on the S.
Oh, yeah. I tried. Okay, next one.
What is that? Why does that
Sin x plus... A lot of people are getting stuck but have done everything correct to that point. So that's good too. So this is why I told you you have to watch with your numerators and denominators, and you have to keep everything as you go along. So this one here, I have a sin x. I'm going to leave it as a sin x over 1. And then tan x is sin x over cos x. I see a lot of people doing this. This is good. Now that's my numerator, so I'm going to put it in brackets so that I know it has to be a full fraction before I can flip that other half, correct? So I've divided by 1 plus cos x over here, which is all over 1. The moment there's a plus sign, this baby is stuck together. The only way it's going away is if it has a matching replica to get it to go bye-bye. That's it, because there's a plus sign in there. You can't, like, even if there was a cos x on the bottom, I couldn't cross them off, right? 1 plus cos x is 1 full term. The plus sign, like, sews it together. So this one here, a lot of people were making common denominators, which is completely correct. They multiplied by cos and cos. People were getting to this spot. It was really good. So we get sin x cos x plus sin x over cos x. Now this is the full fraction, correct? So now I can go times 1 over 1 plus cos x. The whole top goes to the bottom. Now this is the catch. People want to cross these cos x's off. I can't do that. Do you see this top? Sin x cos x plus sin x. That's all attached with a plus sign. Those are sewn together. The only way that's going away is if it has a matching replica or GCF. You can GCF stuff out of it, but you can't cross stuff out of it. Okay? What can I take out of this top left? A sin x. And then I'm left with cos x plus what? 1 over cos x times 1 over 1 plus cos x. Now what do I have happening? I have a cos x plus 1. I have a 1 plus cos x. Are those the same thing?
Yes.
Yes. And then what am I left with? Sin x over cos x, which is just tan x. And what is 1 over cotan x the same as? Tan x, because this is just 1 divided by 1 over tan. Right? So it's the same as 1 times tan over 1. So this is just tan.
Yeah, bro. Go ahead. Mad West.
Okay, everyone has to sit down. Find the y to the negative 3. Okay, I think it's a good house marker. Oh my gosh. So, we started doing these in the geometric unit in grade 11. You were kind of taught how to solve by common base. So, everything that we've solved with so far, we just used bed mass, boom, got an answer, correct? Like, even our exponents would be like a 2 or a 4, or worst case, a quarter or something like that, not even usually. Like 2, 4, 7, and then you just take the third root, or the seventh root, or the fourth root. That was the hardest you could get, correct? But now we're actually doing ones where our variable is in the exponent. And it did happen in grade 11 when you guys would do geometric series. When you'd find like a sum and you'd find the number of terms that added to that sum. They talked about getting a common base. I am not joking. This is the easiest lesson of the year in drawing. I hope you agree with me. Okay, so here we have 2 to the x minus 1 equals 8. You can't always get common base, but when you can, you should. So for all of these, we're going to be able to. What the heck does that mean? That means that we try and make the left side and the right side be the same base. So if I gave you this, if I gave you 2, I was way too happy for this thing, it just moved on me. I gave it too much credit. Okay, if I gave you 2 to the 3 equals 2 to the smiley face. What could you tell me then? Yeah.
The smiling face is equal to 3 minus 1.
Whoa, you're making that way more complicated. You're going grade 11.
The what?
Yeah.
The smiley face is 1.
The smiley face equals 3. You were getting yourself back to n minus 1 formula in grade 11.
I know.
So the smiley face just equals 3, correct? So if you can get your bases to be the same, you then can say that the exponent's equal. We agree? So, can I make these be the same base? That was a smaller base. What can I make them both be? Base 2, right? This one's 2 already, so it's 2x minus 1. We want to make this be base 2. So that means that I need to find an exponent I can raise 2 to that will get me 8. 2 to what exponent is 8? 3. So 8, instead of writing an 8, I can write 2 to the 3. So the first thing we want to do is isolate the power. Write each side with the same power. Or I'm going to say same base because power makes no sense to most of you. Now, if 2 to the x minus 1 equals 2 to the 3, I can then say, well, if 2 to this equals 2 to this, then those thises must equal, the red spots, right? So, once I have the same base, I can say, hey, the exponents must equal. Some people like, cross the bases off. You're not crossing them off. That's not actually real math. You're saying 2 to this exponent equals 2 to this exponent, so then these exponents must equal. And then I can just solve. What do I do? 4, because you're doing what? You're adding 1. So we're going to get x equals 4. What's great about solving, you can always check it. Anytime you solve, doesn't matter what course you're in, doesn't matter what math at all you're in, you can always check. You just plug it back into your original and see if left side equals right side. So I'm going to check it. So it's like a verification. We don't move anything across. We have left side, we have right side, we plug in our x. So we're going to get 2 to the 4 minus 1, and then on this side is an 8. This can be 2 to the 3 and an 8, 8 and an 8. So what did we get? Left side equals right side. So I know I'm right. I can walk away from this feeling like a genius. Right? Okay. B. I have a 9. I have a 27. Both lovely numbers. I can't make 9 or 27 be each other. Some people will say, well, I can divide by 3. Division is not an option here. We need to make common base. So that means we need to make 2 bases that we can raise to an exponent that will get us the same number. Well, that will get us that number, 9 and 27. Is there a smaller number that I can raise to an exponent that will give me 9 and 27, the same number? 3. So 9 is 3 to the what? 3 to the 2. And then I have x minus 1, and I put it in brackets so I don't forget to distribute it. 27 is 3 to the what? 3. So before I drop off the bases, I want to actually distribute the exponent through. So that's why I put the x minus 1 in brackets, because they will have the answer to you going 2x minus 1 equals 3x. We're going to distribute the 2 through. They'll have the answer because that's common error. Okay. So we're going to get 3 to the 2x minus 2 equals 3 to the 3x. Now what can I say? Yeah, so 3 to the exponent equals 3 to this exponent, then the exponents must equal. So 2x minus 2 equals 3x. And then I can solve. So I'm going to subtract 2x. And I get negative 2 equals x. And then I want to verify it. So we're going to get 9 to the negative 2 minus 1, and then 27 to the negative 2. 9 to the negative 3, and then 27 to the negative 2. I think it's 1 over 729. From back brain knowledge, not the actual set. I think 9 to the 3. Yeah. This is 1 over 729. Why is it 1 over? Why would it be 1 over? Because you'd have to drop these underneath the 1 first to make them positive, correct? There would be a step in between here. I could go 1 over 9 cubed, 1 over 27 squared. Okay, when I get a fraction, the first thing I want to do when I have a fraction of a half is I want to make it not be a fraction. What could I raise this to get it to not be a fraction? 2 to the what? How do I move this 2 up? Raise it to what? It's at 2 to the 1 right now. What would it be if I moved it up? 2 to the negative 1. So if I get a fraction, all I have to do is to move it up, I have to raise it to a negative power, correct? It currently is 2 to the 1. So if I want to move it up with the 1, I have to make it be 2 to the negative 1. What common base can I make them both be? You always make them be a smaller base, just so you know. 2. If 16 is 2 to the what? 2 to the 4. Remember, it's exponents. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So it's 2 to the 4. And then this is 2 to the negative x minus 4. And now that your bases are the same, you can set the exponents equal. So 4 equals negative x minus 4. Add my 4 over. 8 equals negative x. 5 by negative 1. And x equals negative 8. And then I can verify it as well. I'm not going to verify it right now. What's the problem with D? I have a 5, a 2, and a 40. Can I make any of them be the same base? No. Is there some math I can do first, though? Yeah. Divide both sides by 5. And the reason why we can do that is because neither of them has an exponent, correct? But some people are like, I don't know if I can. Well, could you do this normally? Can you divide by 5, divide by 5? Yeah, because you can do 40 divided by 5. That's nothing weird, right? So we would get 2 to the x equals 8. Can I make them common base now? What base? 2x and 8. What base? 2 to the 3. If I can make them both, you also make me a smaller base, I can make them both be 2. So this one already is 2, and 8 is 2 to the 3. So then what does x just equal? 3. This one I'm going to star because people forget about this one. They don't spot that you can make this one be a common base. Excessive amount of stars. Everyone forgets about this one. You guys will solve it with a log for the most part. You don't know how to do that right now, so you're like, that must be common base. It's the only thing you've learned. But when you will forget that this can be common base. Whenever anything equals 1, you can make a common base. Yeah. Put it to the exponent of 0, because anything to the exponent of 0 is 1. So when anything equals 1, you can actually make it be the other base. So this base is fine, 6 to the 2x minus 3. And then 1 would be 6 to the 0. Because anything to the exponent of 0 is 1. Exactly right, Kenny. So whenever it equals 1, you can always make it be the other base by raising it to the exponent of 0. Because anything to the exponent of 0 is 1. And now we have same base. So we can just say 2x minus 3 equals 0. Add 3. 2x equals 3. Divide by 2. X equals 3 over 2. So those are the easier ones. We're going to flip over and do the harder ones. They're not like, gosh, awfully hard or anything. They're just a little harder. They're nothing like a trig proof. They're nothing like solving a trig with sum or difference. They're like just a tiny bit harder than these. Okay? The more advanced ones. Why are they more advanced? Because in the previous example, I could divide the 4 over and I'd be done, right? Can I divide a 4 over here? I'm just going to show you what if I do. Don't do this. It's not good. So if I divide the 4 over, some people will tell me it's a half. Well, it's not. This is 4 to the 1. I can only put them together if they're the same base. The last time I could divide them over because both of them didn't have an exponent. Remember on the last question over here, I could divide this 5 over because 40 divided by 5 is 8. That's legitimate. That's been taught since you're little. This I cannot do. 32. I can't divide the 4 over. This has an exponent. Do you see that? They will have the answer to you turning this to a half every single time. It's completely wrong, but that'll be common error. They'll have that answer. So you can't actually divide it over unless both of them don't have exponents. So I can't divide this over, it has an exponent. I can't put this in here. It has an exponent. Do not join these two. Oh my goodness, this happens all the time. 4 times 32 to the x. You guys do it all the time. It is illegal in every state, every province. In none of it, it is bad. Australia, New Zealand, everywhere. China, bad. So, do not do this. If you're like, man, I'm totally going to do that, I would leave myself a little star, 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 and be like, do not put these together. Okay? Do not put those together. And you're like, yeah, I won't. You will. You will. I've seen it. It's bad. It's super bad. Okay? Instead of trying to put that over or divide the 4 over, what can you make them all be? Base 2. Don't put them together. You can't. So this one's going to be 2x to the x minus 3. 4 is 2 to the what? 2 to the 2. And 32 is 2 to the what? It is 5. With an x here. So 4 is 2 to the 2, 32 is 2 to the 5. I'm going to put these ones together and let this sit. 2 to the x minus 3 equals 2 to the 2 times 2 to the 5x. Next error happens. There's so many errors that can happen here. When I have two bases, what am I going to do with those exponents? Add them. How many of you are going to write 10x? A lot. It's the saddest place. If you're that person, you're going to highlight it, and you're going to say, 2 bases add exponents, because that is another error that's going to show up on your multiple choice answer, and you're going to think you're right. You will know you're not right, though, because you're going to check every answer, and it's not going to work, and you're going to go back and be like, what did I do wrong? Okay? So you have to add these. So you're going to get 2 to the 2 plus 5x. You see how we add them, not multiply? And if it's 2 to the x equals 2 to the 2 plus 5x, I can say x minus 3 must equal 2x plus 5. I'm going to do this here. Two plus 5x. And now I just solve, right? So I'm going to subtract my x. And we get negative 3 equals 2 plus 4x. And then subtract my 2. Negative 5 equals 4x. And divide by 4. X equals negative 5/4. And then I can check it by filling it in for all the x's and see if left side equals right side. I'm just solving up to that point.
Is that 2 plus 5?
Yeah. What's my biggest issue for number 2? The 1/9. When I see a fraction, I'm like, get out of my life. That's what I'm saying. Okay. How do I get rid of 1/9? 9 to the what? Yeah, negative 1. 9 to the negative 1 would fix this. 1/9 is 9 to the negative 1. 1/4 is 4 to the negative 1. 1/17 is 17 to the negative 1. 1/20 is 20th to the negative 1. You just raise it to the negative 1 and get rid of the fraction. Okay? So this one here, I'm going to write as 9 to the negative 1, x plus 1, equals 3 to the 1. I'm going to write it as a 1 so I don't try and put those together. 3 to the 1 times 81 to the 2x plus 1. Distribute my negative 1 through. And I get 9 to the negative x minus 1 equals 3 to the 1, and then 81 to the 2x plus 1. So I at least now don't have any fractions. What do I have to do next? What base can I make them all to be? So give it away. 3. So 9 is 3 to the what? 3 to the 2, because 3 squared is 3 times 3. 3 to the 2, and then I have negative x minus 1 behind it in brackets. 3 is 3 to the 1, and I'll always put a 1 because I need to add the 1. 81 is 3 to the, nope, too big. No. 3 to the 2 is 9, 3 to the 3 is 27, 3 to the 4 is 81. And then we distribute our 2 through, so we get 3 to the negative 2x minus 2 equals 3 to the 1 times 3 to the 8x plus 4. Can't drop off my brackets until I put this side together. So this side just stays 3 to the negative 2x minus 2. And this becomes 3 to the what? What do I do with exponents when I have two bases that are the same? What do you do with the exponents? You add them. So I'm going to get 1 plus 8x plus 4. So I'm going to get 3 to the negative 2x minus 2 equals 3 to the 8x plus 5. Then what can I do? I have the same base. What can I do next? Yeah, let's write the exponent equal. So I get negative 2x minus 2 equals 8x plus 5. Add 2x. Negative 2 equals 10x plus 5. Subtract 5. Negative 7 equals 10x. Divide by 10. I guess we want negative 7. Number 3 is our last one. What is the thing that glaringly sucks on this question? The root x. The root x. The root 8. It sucks. But I can write it as an exponent. Whenever you get a square root, whether it's in Math 3-1 or in calculus, you're going to get square roots as well. Whenever you get them, you need to write it as a fraction. So what's the index on this one? It's a 2, and the exponent is a 1. So this is just 8 to the what? 8 to the half. Because I dropped the 2 underneath, right? 8 to the half, 8 to the exponent of half, equals 2 to the what? 2 to the 1. I do not make the 2 and the 16 join. Stop that madness if you feel the need to do it. And then 16 to the x plus 1. What base can I make them all be? 2. So 8 is 2 to the 3. Uh-huh. 2 to the 1. 16 is 2 to the 4. So I'm going to get 2 to the 3 halves, or 2 to the 1.5 if it's easier for you, it's the same thing, equals 2 to the 1 times 2 to the 4x plus 4, because it has to distribute. What do I do before I drop the bases on that right-hand side? Yeah, you're going to have to add those exponents. Because it's 2 to the exponent times 2 to the exponent, so you add them. So we get 2 to the 1.5 equals 2 to the 4x plus 1 plus 4. So 4x plus 5. Right? You have to just add the exponents. Then when we have the same base, we can put the exponents equal. Correct? So we're going to go 1.5 equals 4x plus 5. Subtract 5. Negative 4. That's not true. Negative 3.5. equals 4x. Divide by 4. And x should equal 7 over 8, negative 7 over 8. Mm-hmm. 3 negative 7 over 2 divided by 4 is negative 7 over 2 times 4 is negative 7 over 8. Every single one of these you can check, correct? By plugging it back into the equation and seeing if you get left side, right side, correct? You see these questions? They're your homework. You see how I don't have an answer key? Do I have to give you an answer key? No, why? Because you can check them. I'll give you a hint here for this one. I'll give you a hint for a few of them. This one is going to be 3 to the what? 3 to the 1/2. 3 to the 1/2. This one here, you can just bring this whole thing up and make it be 81 and then minus x minus 3. You have to negate the exponent to bring it up, correct? This one here, 125 and 216, this is 5 over 6 to the 3. I need it to be 6 over 5. This here is 5 over 6 to the power of 3 times negative x over 4. So this is going to be 5 over 6 to the negative 3 over 4. 3x over 4, sorry. But I need it to be 6 over 5. How can I get this to flip? Make this exponent negative. It's already negative, so it's going to turn it to a positive. So try out D7 for homework.
That's the easiest.